Okay, today we're in section 3.4. We're solving inequalities using addition and subtraction. All right, so you don't have to write down the definition. I want it to be, on the recording, and I want to explain it to you. Okay, so an inequality is a statement that's formed by placing an inequality symbol, like what you see here, between two expressions. For example, y plus 5 is less than or equal to negative 6. That is an inequality. So what is the difference between an equation, which is what we've been learning for the past couple of weeks, and an inequality? There really aren't many differences in how we solve them. We solve an equation and an inequality the same way. All right, so I subtract 4 from both sides, 3x equals 12. Divide both sides by 3, and x equals 4. Well, if I'm going to solve an inequality, I literally solve it the exact same way, except I have an inequality symbol here that x is less than 4. So what does that mean? Well, let's go back over here to my equation. Remember how whenever we got a solution, we could do what to check our solution? What could we do to check? We could plug it back into the original problem, right? What's 3 times 4? 12. What's 12 plus 4? 16. Is it true that 16 equals 16? Yes, so it checks out. Everybody remember checking your solutions? Was there any other number that would make the equation true? What if it equaled, what if x was 3? Would the equation be true? No. 4 is the only number that would make the equation true. Well, with an inequality, what we're saying with an inequality is that the solution has to be less than 4. All right, so let's plug in 4. All right, let's plug in 4 back into our original inequality. What's 3 times 4? 12. What's 12 plus 4? 16. Is it true that 16 is less than 16? No, it is not true. So my solution, this is what the inequality is saying. My solution has to be less than 4. So name me a number that's less than 4.
3.
3, 2. Okay, so what's 3 times 2?
6.
What's 6 plus 4?
10.
10. Is 10 less than 16? Yes. All right, now, you don't have to do any of that. The answer is x is less than 4, but I want you to understand what it's saying is that any number less than 4 will make that inequality true. If I plug in a 1, 3 times 1 plus 4, 7 is less than 16. If I plug in any number. So is there just one solution? No, there's literally millions of solutions. That's the difference between an equation and an inequality. Now, when we're talking in terms of words, all right, the first section of your homework tonight deals with inequalities that are written as words, and I have to actually write an inequality. What I'm looking for is numbers like less than, or at most, or greater than, or less than or equal to. I'm looking for these key words to help me determine what type of inequality sign I'm writing. So if I have the inequality x is less than 3, I represent that with an open dot on the 3. Here's what I'm saying. 3 cannot be a part of the solution. Because is 3 less than 3? No, it's not. Is 2 less than 3? Yes, it is. So that can be a solution, but 3 is not a part of the solution. Open dot. And then my arrow goes left because it's less than. All numbers less than, well, they're going to go left on the number line, right? So if it's less than, my arrow goes left on the number line. If it's greater than, notice which way my arrow is going. Which way is my arrow going? It's going right on the number line. And again, I have an open dot because it's just greater than. Well, now notice with z is less than or equal to 4. Now, less than or equal to 4. Can 4 be a part of the solution? Yes, it can, because equal to, well, we all know what equal to means, right? It means the same as, the same value. So that's why now we have a closed dot anytime I have the equal to symbol in my inequality. I have a closed dot on the 4 because 4 can be a part of my solution. Same thing with my last inequality. N is greater than or equal to 2. That's why I have a closed dot on the 2. It can be a part of the solution. And my arrow is going to the right because it's greater than. All the numbers greater than 2 will make it true. All right? Any questions on how an inequality can be graphed on a number line? Any questions? So now let's look at our first word problem. The freezing point of water is 0 degrees. So there's the number that we're comparing. 0 degrees Celsius. Freezing point of water. So if water is 0 degrees Celsius, will it freeze? Yes, it'll freeze. It says 0 degrees. At temperatures at or what? At or... So can they be above 0 and freeze? Okay. The freezing point, water is solid. Write an inequality that gives the temperatures at which water is a solid. So temperature, well, you can just use T. Does it have to be less than or greater than 0?
Less than.
Has to be less than. Can it be 0 and still freeze? Yes, it can. Because it says at or below. Okay, so it can be 0. So T is less than or equal to 0 degrees Celsius. Now, all of your inequalities that you solve, you are going to graph on a number line. So your solution, in this case it's 0, that's always going to be your middle number, 0. And then you're going to have 2 numbers on the right and 2 numbers on the left. And make sure that you write the numbers. Okay, what's the next number greater than 0? 1, and then 2. What's the next number lower than 0? -1 and -2. Okay? Now I need to decide, do I have an open dot or a closed dot? Open or closed? No. It's closed because can my solution be 0? Yes, it can be equal to 0. So it's going to be a closed dot. And since it's less than, my arrow is going to go to the left. All right, so now let's look at example 2. Now the good news is, like I said earlier, you're going to solve an inequality the same way that you solve a solution. So how do you get m by itself? What do? Everybody should know this, right, Isaiah? Okay, what do? Subtract 5 from both sides. All right, and now m is greater than or equal to what? 5. Okay, that's my solution. That's part of it. Now I need to graph my solution on a number line. So here's my number line. What number goes in the middle?
0.
No. My solution goes in the middle. 5 goes in the middle. Now what's the next number after 5? Going to the right. 6, and then 7. What's the next number below 5? 4, and then 3. All right, now I need to decide, is it an open, Isaiah? Is it an open or a closed dot?
Closed.
It's a closed dot. And is my arrow going left or right?
Left.
Whoa. M is greater than or equal to 5.
Right.
It's greater than. Okay, I've got to draw my numbers, my arrow to the numbers that are greater than 5. Now, here's what it's saying. Okay, let's choose a number greater than 5. What's a number greater than 5?
6.
Okay, 7, 10. Let's choose 10. What's 10 plus 5 if I plug it in? It's true that 15 is greater than or equal to 10. So by my graph, I'm saying that all numbers greater than or equal to 5 will make my inequality true if I plug it back into the original. All right, I want you to try B on your own. All right, so let's work it out. Subtract 12 from both sides. Did you get D is less than or equal to 12?
Yes.
All right, now so 12 is my number in the middle of my number line. What goes next? 13 and 14. What goes below the 12? 11 and 10. Now here's my big question. Open or closed dot?
Closed.
Closed because it's equal to. And does my arrow go right or left? It goes to the left. All right. Okay, who got it all right? Did you get it? Okay, good. So we're catching on a little bit. Now I'm going to change up example C here real quick. I'm just going to change it up a little bit. What if I had 17 is greater than r plus 7? Now my variable is on the other side of the inequality, and it does change the way that I read it. It doesn't change the way I solve it, though. If I subtract 7 from both sides, I end up with 10 is greater than r. But I need to read it variable first. If I don't read it variable first, odds are my arrow is going to go in the wrong direction on my number line. I need to read it. R is less than 10. R is less than 10. So on my number line, 10 goes in the middle, 11 and 12, 9 and 8. Open or close dot? Open, but notice, guys, this is very easily confused. If you read it 10 is greater than R, you might try to do your arrow to the right, but that's not true. Have to read your variable first. R is what? Less than 10, arrow goes left. You can test your solution. What's a number less than 10?
2.
What's a number less than 10?
4.
Okay, 2. Is it true that 17 is greater than 2 plus 7?
Yes.
Yeah, 2 plus 7 is 9. All right, so you can test your solution to make sure that you're correct. All right, next example. Okay, so now, again, I've got my variable on the other side, but what do I do to solve for x?
You gotta make it.
I need to, how do I get rid of negative 12?
Add 12 to
Add 12 to both sides. Okay, and I get, what's negative 10 plus 12?
2.
Positive 2 is greater than x. But is that how I'm supposed to read it?
No.
How do I read it?
X is less than 2.
Yes, x is less than 2, so make sure you do that. So on your number line, I've got 2, 3, and 4, and 1 and 0. If x is less than 2, open or close dot. And which way does my arrow go? Left. It goes to the left because x is less than 2. All right, I want you to try to work B and C. All right, so on B, B is less than 28. Open dot, going left. On C, S is less than or equal to 21. Close dot, going left. Did you get them? Did you get both? Okay, so guys, on this example, you have to read the wording, okay? It says the triathlon, you're competing in a triathlon sports competition with 3 events. Last year you finished in how many minutes?
85.
85, so that's your total. Okay, you finished in 85 minutes. The table shows your times, so here's the table. It shows your times for this year's first 2 events. What possible times can you post in the running event, and what?
Still beat last.
So if you're going to beat it, can you have the same time?
No, you have to get less.
Can it be greater than 85?
No.
If you're going to beat it, it has to be
Less.
less than. So I'm going to add 17 plus 45 plus maybe R for running is less than 85. So now 17 plus 45 gives me 55, 62. 62 plus R is less than 85. Subtract 62. And R is less than 23 minutes. So let me ask you this. If you run it in 23 minutes, will you be less than 85?
No, you'd be on the dot.
You'd be tied. You'd be tied. So, but if you run it in 22, will you beat it?
Yes.
Yes, you will. All right, so we're just setting up an inequality and we're solving. And if you, there's one more thing. I'm glad I remembered this. Okay. Now, what if you have what we call a compound inequality? Let's say we have x is greater than 3, but x is less than or equal to 10. Okay? So now I have what I call compound inequality. I have 2 that I'm graphing on the same number line. All right, so my number line needs to start maybe a little bit below the 3 at a 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. 6, 7, 8, 9, 10, and 11. All right, now I'm going to plot my point on 3. Is it going to be an open or a closed dot?
Open.
Do you see a equal to underneath here? Nope, there's nothing there, so it's going to be an open dot. And is it going to be an open or a closed dot on the 10?
Closed.
A closed dot on the 10. And now you're just going to draw a thicker line to connect the 2 together. All right, so a thicker line to connect the 2, and that's how you graph a compound inequality. If you understand that, that's everything you need to know for the lesson today and for your homework tonight.